Kind of a fun one. Again, evaluating a limit at a point, what's the first thing you should do? Before you do any work, plug it in. If you get a number, that's the limit value. If you get a number over 0, the limit doesn't exist. You got an infinite discontinuity there. If you get 0 over 0, that is the indeterminate form, so that's where you have to start doing some extra work. Does that make sense? Okay, guys? Alright, so in number 9, what do you have to do to evaluate that limit? It equals 0 over 0, so what do? Yeah. Does that make sense? You can factor a 2 out of the numerator. You guys see that? That was like a tricky, easy, tricky one. Yeah, I'm doing the algebra ones, you guys. Sorry. On the algebra ones, you factor a 2 out. In 11, now this is something that I'm not going to test on tomorrow, but that's a sum of cubes. We've seen difference of squares, and there were a ton of difference of squares on this packet, yes? They're all over the place. Well, there's something also called the difference of cubes and sum of cubes. And I'm just going to write those down again. I'm not going to test it tomorrow on it, but just so you know it, you got something like a cubed plus b cubed. That's equal to a plus b times a squared minus ab plus b squared. It's another way to factor. Just like difference of squares, it's a little pattern with sum of cubes and difference of cubes. A minus b, a squared plus ab plus b squared. Now these, I'll never tell you to memorize. And actually, I don't memorize them. I know kind of the general form. And then what I'll do is I think it's something like this, but like yesterday when I was trying it, I'm like, is this a 2 here or something? And then I'll just multiply this back out to see if I get what I started with. You know what I'm saying? That's what I do to kind of help me figure these out. I know, what I do remember about sum and difference of cubes is that if this is a plus b, this is a plus b. If this is a minus b, this is a minus b. And I know overall there's one subtraction sign somewhere in there. This one is one subtraction sign. This one is one subtraction sign. And I remember that this is a squared and that's b squared. And then I kind of figure out the rest if I'm in a situation without a calculator and I need to factor it. Okay, guys? So in this case, in this 11, you have t cubed plus 8, the limit as t approaches negative 2, t cubed plus 8 over t plus 2. And this thing factors to t plus 2 over t squared minus 2t plus 4 all over t plus 2. And there you get your canceling out right there. Again, the first thing you should do is plug in the value of 2. You get negative 8 plus 8 is 0, negative 2 plus 2 is 0. Since you have a 0 over 0 form, now we have a little more work to do. Okay, guys? And then these cancel out right here. And now you can plug in. You get 4 plus 4 plus 4. You get 12 in that case. Okay, does that make sense, you guys? That's a, what was this one? A sum of cubes. Alright, that's number 11. Number 14. How do you solve that one? You have to do synthetic division. Give it a shot. What do you do first for synthetic? You get 0 over 0, so something has to factor out. The only trick I know for a cubic try it in your group. See if you can use synthetic division to factor this to see what cancels out. And again, to algebraically evaluate this limiter, to determine the limit. You should get these factors. These cancel out. These cancel out. leaving you with x plus 3 over x plus 2, and you can plug in at that point. There's your limit. Okay? Is that what we got for the factors, you guys? Alright, you guys, check out 17. Take a look at 17, you guys. What does this limit equal to? Why in 17 does this limit not exist? It's a difference of squares. Something cancels. Doesn't it cancel, Anna? You guys, this is an interesting function. This function has a removable discontinuity and an infinite discontinuity. And it actually asks for the limit at the infinite discontinuity. First thing you should do is plug in. If you plug in, you get 12 over 0. Does that make sense? If you did the completely separate problem, let's do a new problem. New. Limit as y approaches negative 6 of y plus 6 over y squared minus 36. And you plug in, and what do you get?
0.
Okay. Indeterminate form. We got some work to do. A little investigative reporting going on. What do we call this thing? Difference of squares. What does it factor to? Okay. These cancel out, leaving you with 1 over a negative 12 after you plug in. Does that make sense, you guys? This is a little tricker one. Why, that's 17. 25. How do you do 25? This is new. This is new. This is 17. You're correct. Infinite discontinuity at 6. Negative 6. The limit exists. Why were you confused?
Because I didn't That's the only reason.
So with 17?
Yeah.
Infinite discontinuity. Great. Here's a new problem. All right. How do you multiply out 25? You can't. You plug in first, and what do you get in 25?
So, no. The limit as this approaches 7.
You plug in x equals 0, and you get 0 here, so square root of 4 is 2, minus 2 is 0 over 0. You get indeterminate form. So next thing you need to do is try to factor anything. Well, there's just an x in the denominator. Not the reciprocal, what do we call it? The conjugate. What is the conjugate here? Plus 2. This conjugate is the square root of x plus 4 plus 2. So I don't change this. I'm going to multiply by 1. So same thing on top, same thing on bottom. And then you FOIL that numerator. Square root of x plus 4 times square root of x plus 4 is x plus 4. 2 times the square root of x plus 4 plus negative 2 times the square root of x plus 4 is, they cancel out, and then negative 2 times 2 is minus 4. And I'm not going to multiply out this denominator. I'm going to just say they're multiplied by each other. Because then in the numerator, these cancel out, so you just have x up top. You have x divided by x times that whole thing. The x's cancel out. Again, look for that anytime you see the square root of something and then minus or plus.